Hi everyone, in this video we will be adding and subtracting polynomials. This is lesson 8.1. So really what that means is that we're going to be combining like terms. So in this first problem we have 3 of the t to the fourths plus 11 of the t to the fourths. So altogether we have 14 of the t to the fourths. So key idea is that we are adding or subtracting the coefficients of the like terms. So these are both like terms because they're both t to the fourth, and we are not changing the exponent. So altogether we have 14t to the fourth. So in this problem we are adding two polynomials. In here we're adding, and the two polynomials are separated by the parentheses. But adding the two polynomials, so if there's a number 1 out front, and we distribute that 1, the parentheses goes away, and we just have 2k squared minus k plus 3, and distributing the 1 plus 5k squared plus 3k minus 7. So the parentheses really were not necessary. So now I can just combine like terms. I have 2 of the k squares plus 5 of the k squares, so altogether 7k squares, then minus 1k plus 3k, so plus 2k, and then finally 3 minus 7 is negative 4. So the final answer, 7k squared plus 2k minus 4. In this problem, same idea. The parentheses do not matter because we're adding. So distributing 1 would not change. So I'm able to combine like terms. Okay, so I have x to the third, x to the second, and x, and a constant. Okay, so combining like terms, I'll have 3x to the third. Then combining the squares, I have 7 of the x squares plus 8 of the x squares, so altogether 15 of the x squares. And then take away 4x, take away 6x, so minus 10x. And finally minus 5 at the end. So there's my final answer. I have 4 unlike terms, so I am done. This problem's a little different because of this minus. So if I put a 1 here, I have to distribute the negative to all the terms in the parentheses. So then I'd have minus 5r squared minus r minus 8. So distributing the negative switches all of those signs. But this just has a positive 1 here, so that parentheses does not matter. I can write down negative 9r to the third plus 2r minus 1. So combining like terms, I will have negative 9r to the third, and then negative 5r squared, and then 2r take away 1r is plus 1r, so just plus r, and finally negative 1 minus 8 is negative 9. So I have my final answer. In this problem, distributing the negative, I'll have negative 6y to the third minus 4 plus 6y squared. So that distributes the negative, opens up the parentheses. For the first one, the parentheses do not matter, so I'll have y to the third minus 4y squared minus 2. I'm ready to combine like terms. So 1 minus 6 is negative 5y to the third. Negative 4y squared plus 6y squared, so plus 2y squared. And finally, negative 2 minus 4, so negative 6. So my final answer. In this problem, distributing the negative is going to give me a positive, because 2 negatives is the positive, so I'll have plus 5x to the fourth minus x to the third plus 1. Bringing down the others, 3x to the third minus 6x plus 2. So combining, I'll have 5x to the fourth, 3x to the third minus 1x to the third, so plus 2x to the third, takes care of that one. And then minus 6x, and 2 plus 1 is 3. So I have my final answer. Last problem, I have 2 of the m cube n cubes plus 9 of the m cube n cubes. So altogether, I have 11 of that, m to the third, n to the third. So all I'm simply doing is combining the coefficients since my variables and exponents are identical. 2 apples plus 9 apples is 11 apples. That gives my answer.